Today we're going to be looking at section 6.3, which is on performing function operations and compositions. Our goal is to perform operations with functions. So we're going to be taking some functions today. We'll call them f of x, g of x, h of x, and we're going to be combining them using different operations, whether it's addition, subtraction, multiplication, or division. So that's what we're going to be looking at today, how to perform those operations with some given functions. Operations of functions, it says let f and g be any two functions. A new function h can be defined by performing any of the four basic operations of f and g. So here we're going to take the functions f of x equals 5x and g of x equals x plus 2. And the first operation we're going to look at is an addition. We're just adding the two. So h of x equals f of x plus g of x. So we're going to put in f of x. F of x is 5x, and g of x is x plus 2. So we're going to simply add our like terms. So h of x is going to simply equal 6x plus 2. When we talk about the subtraction, same thing. We're putting in f of x and g of x. So we're going to have f of x. That's going to be minus x plus 2. However, in this case, notice we have a minus and then the parenthesis x plus 2. We have to use the distributive property for that. So it's going to be 5x minus x minus 2. And so our function is going to be 4x minus 2. So now our new function h of x would be 4x minus 2. Multiplication. Again, we're going to do the same thing. We're going to multiply the two functions together. So we're going to have 5x times x plus 2. And in this case, we're going to use the distributive property. 5x times x is 5x squared. 5x times 2 is 10. And so we have 5x squared plus 10. And the last one we're going to talk about is the division property. And we're going to put our 5x in the numerator and our x plus 2 in the denominator, f of x divided by g of x, and then we're going to reduce it. Well, in this case, there's nothing we can do to reduce it, so that is simply our answer. All right, the domain of h consists of the values that are in the domain of both f and g. Also, the domain of the quotient does not include x values for which g of x equals 0. Next thing we're going to talk about is something called a power function. And a power function is a function of the form y equals a times x to the b power, where a is a number and b is a rational number. So we're just going to use these power functions now to do the same type of thing. So in example 1, we're going to take f of x plus g of x. So f of x is 5x to the third. G of x is negative 11x to the 1/3. And so now we add these. Well, that's going to give us negative 6x to the 1/3. So that is our answer for that one. Next one, f of x minus g of x. So we're going to have f of x to the 1/3 minus negative 11 x to the 1/3. And now that's going to be 5 minus negative 11, so that's 5 plus 11, which is going to be 16x to the 1/3. All right, now remember, x to the 1/3 can be written as the third root of x. So in this case, you could see your answer as that. And in this case, you could have your answer written as negative 6 times the third root of x. So both of those are acceptable answers. Now for part C, it says find the domain of f plus g and f minus g. So in the first one, if we look at our domain, remember again, the domain is the x values. If we look here, are there any numbers that I cannot put into x? If I put in 0, well, the third root of 0 is 0. 0 times negative 6 is 0. Comes up with an answer. Okay, so that's why I write it in this form a little bit. It might be easier for you to use to find out what the domain is. So no matter what number I put into that, I will get an answer. So my domain is all real numbers. Likewise, the second one is going to be the same. There are no values of x that I could put in here that would not make it a real solution. If I take the third root of 8, that's 2. 2 times 16 would give me 32. That's a solution. If I put in negative 8, the third root of negative 8 is negative 2. Negative 2 times 16 is negative 32. If I put in 0, third root of 0 is 0. 0 times 16 is 0. So I'm going to get the answer 0. So no matter what, again, I put in any number there, I'm going to get a solution. So the domain in this case, again, is all real numbers. So let's jump down to example 2. We're going to multiply and divide functions now. So f of x here is 8x. So we're going to have 8x times g of x, which is 2 times x to the 5 6. So we're simply going to multiply these. 8 times 2 is 16. And then I have x times x to the 5 6. Well, this is going to be really, this exponent is 1, which is equal to 6 6, because we have to add our like terms. We have to get a common denominator to add those. So this is going to be x to the 11 6. And again, I'm going to write this as 16 times the 6th root of x to the 11th power. Either one of these two is an acceptable answer. It just depends on whether you like it in rational exponent form or radical form. So we're going to do the same thing with f of x and g of x, dividing them in part B. So we're going to have 8x in the numerator and 2x to the 5 6 in the denominator. Again, 8 divided by 2 now is 4. And again, this is going to be 6 6, because that's a 1. So 6 6 minus 5 6 is 1 6. So that's x to the 1 6. And again, I'm going to write this in radical form. And you can write it whichever way you want. It just might help us see the domain in this case a little bit better. So we're going to talk also now about the domain. All right, so if I put in a number that's positive, it works. Like I put in 1, the square root of 1 is, or 1 to 11th is 1. The 6th root of 1 is still 1. 1 times 16 is 16, gives me an answer. If I put in 0, same thing, that's 0, gives me an answer. If I put in a negative number in here, I cannot take a 6th root of a negative number. Just like remember when we had negative numbers inside our square roots, it was imaginary. The same thing is true here. Because we have an even number of negative signs, it's not going to come out to a real number. It will be imaginary. So if this index number is even 2, 4, 6, 8, 10, that's an even number, then you cannot have any negative values. Okay? So in this case, the domain is going to be x must be greater than or equal to 0. And in the book, they're going to write it as all non-negative real numbers. So that's our domain in this case. All non-negative real numbers. 0 works, and the positive numbers work. So then, if we look at B, the division one. Same thing is true here. If we look at the domain, your negative numbers will not work in this case because that has an even index number. So in this case, we also have to check one other thing. And in a division problem, we want to look at this. Are there any numbers that will give me 0 in the denominator? Because you can never have 0 in the denominator. So in this case, if I put 0 in here, I will get 0 in the denominator, and you can't have that. So I can't have 0, and I can't have negative numbers. So in this case, x must be greater than 0. That's our domain. In the book, you're going to see them write all positive real numbers. So that's our domain in this case. There are restrictions on which numbers we can use, because if we put in -4, or let's even say -64, because the sixth root of 64 is 2. So the sixth root of -64, well, it would be -2 inside that radical, but we can't have that negative because it won't work. We need an odd number, or an even index is going to tell us that we have an even number of negative signs, which will be a positive number. All right, so looking at example 3, we're going to solve a problem. It says a small company sells computer printers over the internet. The company's total revenue, or monthly revenue, R and C are modeled by the functions R of x is 120x and C of x is 2,500 plus 75x, where x is the number of printers sold. So x is the number of printers sold, R is the revenue for the month, and C is the cost for the month. We want to know what we want to find R of x minus C of x. So we're going to just simply write those in. We're going to have 120x minus 2,500 plus 75x. Well, and once again, we're going to go 120x minus, do the distributive property here. And so we're going to end up with 120 minus 75, which is going to give us 45. X minus, and then 2,500. And so there is our answer. Now, it says explain what this difference means. What does this mean when we subtract these two? Well, that is going to be how much the company made. So it's the company's monthly profit. And usually we're going to call that P of X. And so here is the monthly profit. All right, so go ahead and do the guided practice questions 1 through 6. You can go ahead and pause the video and hit play when you're ready to resume. Looking at our guided practice questions 1 through 6, here are those answers. Notice in number 5, the domain cannot be 0, not because of the answer we got. We had 3 times x to the 4/5. Any number works there. However, when we look back at how we set this up, we had x to the 1/5 in the denominator, and that can never be 0. So the domain is all real numbers except 0. The next thing we're going to talk about is the composition of functions. And the composition of a function g with a function f is h of x equals g of f of x. The domain of h is the set of all x values such that x is in the domain of f and f of x is in the domain of g. So what we're going to do is look at a couple of examples. Now here our goal is to find f of g of -3. So we're going to start from the inside out. We're going to take this part of it, the g of -3, and we're going to find that. So realistically, all we're doing is putting -3 in for x. So g of -3, so it's going to be -3 squared minus 1. So -3 squared is 9. 9 minus 1 is 8. So this is going to be f of 8. So now we're going to take that and we're going to plug it into the f function because now we have to find f of 8. So really, we're just putting it in there. So now this is going to equal 3 times 8 minus, I covered that up, minus 4. So this is going to be 24 minus 4, which is 20. So f of g of -3 equals 20, which is C. So you're always going to start with the inside. We've found like g of -3 hundreds of times, so you just got to find that. Then, whatever that answer is, and in this case it was 8, you just took 8 and plugged it into the f of x function. So we found f of 8. So now in example 5, we're going to do the same thing, only we're going to find f of g of x instead of f of g of 3. So what that really tells us to start with, we're finding g of x. So we're going to take g of x. Here's g of x. And we're going to plug it into the f function. So we're going to start on the inside. We're going to move it to the other one, the one that's on the outside. So really, f of g of x is going to equal 6. Now instead of x, I'm going to write the g function, which is 4x plus 5, and then to the -2nd. So realistically, I'm just replacing the x with the 4x plus 5. And now we simplify it. So f of g of x equals, well, that's a negative exponent, so I move it to the denominator, 4x plus 5 to the -2nd. And we'll just look at the domain right away. Are there, oops, that should be a +2, because we moved it down. So we're going to look at the domain right away. Are there any values of x that cannot be true? And so we have a denominator here. So what we would really want to do is look at what makes this 0. Because you can't have 0 in the denominator. And that answer is -5/4. So x cannot equal -5/4. So it's all real numbers except for -5/4. All right, so if we go to B, now we're finding g of f of x. So realistically, we're taking the inside function again, which is f of x, and we're going to plug it into the g function. So we're going to go start with the g, and it's going to be 4. Now instead of x, we're going to write whatever f of x function is. So it's 6x to the -2, and then plus 5. So this is going to give us 4 times 6 is 24. Then the x to the -2nd is going to move to the bottom, plus 5. So g of f of x equals 24 over x squared plus 5. And the domain has to be any number that works. Well, we do have one number that's not going to work, and that is x cannot ever equal 0. And the reason is because that would make our denominator 0. All right, and then the last one we're going to look at is g of x. So essentially what we're doing here is we're going to take the g function, which is right here, and we're going to put it back into itself. So we're going to take this and we're going to put it back in for the x. So we're going to start with that, 4. Now instead of x, we're going to write 4x plus 5, and then we have the plus 5 left. So the g of x is going to equal 16x plus 20 plus 5, which is 16x plus 25. So that's our g of f, or of g of x function. And then the domain, when we look at this one, are there any restrictions on this problem? And there are not. There are no restrictions on this domain, so it is all real numbers. And that's how we find the composite function. Remember, whatever one is on the inside, we're going to take that and we're going to plug it into the one on the outside. So if it's f of g of x, I'm taking the g of x function, plugging it into the f, into the x of the f function. In 2, it's g of f of x. So I'm going to take the entire f of x function and I'm going to plug it in for x in the g function. In C, I took the g of x and I plugged it back into the g function for x. Next, we're going to look at example 6, and it's solving multi-step problems. It says your starting wage for your part-time job is $6 an hour. An employee gets a 5% raise after 6 months. You are given an additional raise of 75 cents per hour as a reward for your outstanding work. Find your new hourly wage if 5% raise is applied before the 75-cent raise. All right, so here's what we're going to look at. You make $6. Now it says you're getting a raise of 5%. So you're going to get your raise first. So that 5% is 0.05, which means that is 30 cents. So you get a 30-cent raise. So now your new hourly wage is $6.30. Okay. Well, if now you got a 75-cent raise on top of that, so we're going to say plus 0.75. Now you're going to end up making $7.05 per hour. So your wage is $7.05. Right. So that's how much you would make if it was applied this way. Now I want you to think a second. Are you going to make more or less than this if we look at example B? B says find your new hourly wage if the 75-cent raise is applied before the 5% raise. So we're going to make more or less if we give that 75-cent raise first. Well, let's check it out. So again, you start at a salary of $6, but you're going to add the 0.75 right away. So now you're at $6.75. So now on top of that, here's your $6.75. You got a 5% raise just because you do. And so that is 0.3375. So if we take that and add your 6.75 to it, your new salary is about $7.09 per hour. It's just a little bit more than 7.08. But so your wage is 7.09. So if you had the choice here, you should pick have your raise, the 75% raise, put on first, because then we're taking 5% of that rather than 5% of your starting salary. All right, so we're going to jump to a few guided practice questions. I would like you to do questions 8 through 12, and then you can go ahead and pause the video when you are ready. Or pause the video now, and then you can resume it when you are ready. And here are the answers to your guided practice questions. Notice we found the domain of all of the ones in questions 12, and you have to make sure to look at the restrictions on those functions. So looking back at this section, we're looking at composite functions. We're taking two functions, an f function and a g function, and we're putting them together. Now in some of the examples, we found like g of 3 and then plugged that in. In other functions, we're just using the two functions and putting them together first. And then we are also looking for the restrictions on those. So essentially section 6.3 is on combining functions using different operations and also using composite functions to simplify these and put these two functions together. So your homework assignment is on page 432.